everyone. So we're moving on to our next section, which is 12-5. Okay, so this section is about inscribed angles. Inscribed angles. Okay, I can give you the definition right away, but there's something I want you to understand first, and then we'll just drive the definition from that. First of all, this is something you should know. Okay, this is arc AC. If I ask you to find the measure of arc AC, can we do that? Okay, so what I see is this is the central angle. Let me pick a different color. So this is the central angle. As we learned about this before, that the arc measure always going to be same as central angle. So if I see the central angle is 90, so you know measure of this AC arc would also be 90 degrees. Now I'm going to draw another angle, and then you'll see the difference between central angle and the new angle, which we're going to be learning in the next few seconds. So let me pick a different color. So now this is my other angle, which we call as inscribed angle. Okay, first of all, if I ask you to figure out this inscribed angle, which is this part here. First of all, do you think it's same as, okay, let me just label this. This is number 2. This is number 2. Do you think that angle, which I say inscribed angle, do you think that angle is same as angle number 1, which is the central angle? Even though if you look at it, it doesn't even look the same. So I feel like inscribed angle looks smaller than central angle. Isn't it? And that's what we're going to be learning about. Now, let's just look at the difference between central angle and the inscribed angle. First of all, if I say central angle, the edge of that angle, it's always going to be just at the center of the circle, which is here. So that's the central angle. But now when I say inscribed angle, so the edge is not on the center point. Instead, it's on the circle. It could be anywhere on the circle. So this red one is actually the inscribed angle. What's the relationship? So central angle is always same as the arc length, the arc measure. But what about the inscribed angle? So the inscribed angle, let's just say this is angle B. So I would say angle B would always be half of the arc measure. So it's always going to be half of measure of this AC arc. Or you could even say other way around. So the arc measure would always be twice of angle B. Keep in mind, so that inscribed angle which goes on the edge of the circle, it's always going to be less than the arc measure. The exact measurement is it's always going to be half of that arc length. So that's what inscribed angle is. So if you want to take kind of quick definition of inscribed angle, so I'm just going to say inscribed angle, it's always inside the circle whose vertex, or you want to call it edge, either or, whose vertex is on the circle and whose sides are chords of the circle. All right, I guess once I explain this whole circle here, so you should understand what an inscribed angle would look like. All right, keep in mind, inscribed angle's edge always going to be on the circle. It's never on the center point, because if it's going to be on the center point, it's called central angle, which is same as the arc length. Okay, but the inscribed angle always going to be half of the measure of the arc length. Okay, all right, so let me show you a few examples. So here comes the first one. Let's say here's a circle. This is the inscribed angle, and let's just label this one as A, this is B, and this is C, and this one is 50. Can we find measure of AB? Can we figure out the arc length since we already know the inscribed angle? So it's always, arc length will be twice of the inscribed angle. So I know this arc measure would be 100 degrees, okay? I have a few more examples. So let's say I have this circle here. This is my inscribed angle. So what I know is this arc, let me pick a different color, that goes from A to B is 80 degrees. A to C is 40 degrees. So how about solve for this angle? Can we do that? So isn't it, in order to solve for that angle or the arc, you have to have one of those variables. If not, then it's going to be hard to figure out the information. But what I can do is, I know rest of the stuff. I have some supplementary information there. So what I know, the AB part is 80, which is this part on the circle, and AC, which is this part here. So 80 and 40. So I know from B to C, the total is 120. And you know, on the entire circle, I have 360 degrees. So can we figure out part BC, which is this part here? Can we do that? Because once I have that measure, I can figure out inscribed angle from there. So how would you do that? So I would just add 80, which is this part here, add it to 40, and that becomes 120. If I take away from 360, which is going to be 240. So I know the arc measure from B to C is 240 degrees. Since I already know the measure of that arc, I could just take half of that. So that's going to be angle X. So 120 degrees. Okay. I have a few more. So how about this circle here? I have one line goes like this. Another one goes here. This one here. So I have 140 degrees here, 80 degrees here. So that's what I know so far. Okay, let's figure out all of the details here. Let me just label a few things: A, B, C, and D. Okay, what's the first thing we could do? Do we have any of the inscribed angles? Yeah, the first one I see is 80 degrees, and from there I can find arc measure CD. So if this is 80 degrees, this arc measurement would be 160. Okay, what else do we know? So I know, think about this, isn't it? This is half of the circle. It means from here, how come I know it's half of the circle? Because isn't it passes through the center point, so that's definitely going to be the diameter, right? So on this side of this circle, this entire arc would be equal to 180 degrees, which I know from A to B is 140. So can we figure out BC from there? So that would be 40 degrees, okay? Since I already know measure of arc BC, can we figure out the inscribed angle from there? So since this is 40, so inscribed angle correspond to that would be 20 degrees. Okay, almost there. So now the entire circle, you know it's 360 degrees. You already have 180 for this half, the top half. You already have 160 here. So you know this leftover part would be 20 degrees. And yeah, that's pretty much all I have about this problem. So basically the idea is you should be able to identify those inscribed angles and the corresponding arc. If you could figure out that, then you could just go by the relationship and find the angle or the missing information here. So I have a few properties about inscribed angles which would make your life way easier, because if you could figure that out, you can just apply the property and get the answer right away. Think about this one here. So I see two different inscribed angles here. So I see the first one here, second one here. So isn't it they both share the common arc? So let's just say arc AB. So both of these inscribed angles, which is C and D, share the same arc. So what's true about angle C and D? Angle C would be equal to angle D because they share the same arc. Anytime you see something like this, you can just apply the property. So that's the first one. Another one. let's say this is the diameter. And here's the inscribed angle. So now I know this inscribed angle, which goes from A to B. It has exactly half of the circle in front of it. Means the arc measure for that one, it's 180 degrees. So what would be the inscribed angle? So that would be 90 degrees. Or you could say anytime any inscribed angle goes right across semicircle or half of the circle, the inscribed angle always going to be 90 degrees. Okay, one last property. So the last property is, if you have a circle and inside the circle there is a quadrilateral, means a four-sided shape. So what's true about the four-sided shape? So it means this opposite angles of this four-sided shape always going to be supplementary. So I would say angle, let me just say angle 1, angle 2, 3, and 4. So angle 1 plus angle 3 would be supplementary or equal to 180. And same as angle 2 and angle 4 would also be equal to 180 degrees. And all four angles always add up to 360 degrees. So these are few properties you could always use to actually make your life easier. So I'm just going to show you one last example, and that's going to be all for the day. So here's a circle. I have first inscribed angle here. So let's just label this A. This is diameter. This is B. This is C. This is D. And I know this is 40. This is 70. And we need to figure out rest of the stuff in here. So that inscribed angle here. And there's one more. There's another line here. Okay, first of all, so if I ask you to solve for angle A, which is my inscribed angle here, I have to have my arc measure right across. So arc measure would be 40 plus 70, because this arc goes from C all the way to D, and I know BD is equal to 70, CB is equal to 40, so combine it's 110. So I know this angle right across, which is its inscribed angle, would be 55 degrees. Okay, that's the first thing I know. How would you find this angle X degrees? Let's just say angle X. Okay, so what I see is, let me erase these markings first. Let me just erase this. I'm looking for this. This one we already know 55 degrees. Okay, so if you look closely, isn't it? This angle is right across half of the circle, which is equal to 180 degrees. Or you can say the line right across, it passes through the center point. So it means this whole arc is 180. So the angle cross, or the inscribed angle, would be 90 degrees. Here you go. So pretty much, yeah, that's how you deal with these type of problems. And if you don't understand any of these things, you can actually pause the video, go back. If not, you can comment and I can help you with that. So yeah, this is pretty much all. Bye-bye. Thank you for watching. Bye-bye.